Good evening, my dear students. I welcome you all for today's automation and robotics class. Today I am going to discuss about the tactile sensors. Okay, what is tactile? Okay, it is relating to the sense of touch. So, in tactile senses, the tactiles means relating to the sense of touch. So, the tactile sensor is a device that measures the information that is arising from physical interaction with the environment. Okay. So, during the operation, whenever this you are uh, taking this sensor towards the object. Okay. It's These tactile sensors will measure the informations arising from the physical interaction with the environment. Okay, you can see that in this particular diagram. So this particular robotic no hand, this particular finger, it will have the tactile sensors. Okay, whenever you are making that object, okay, by touching that surface, okay, it will interact, that sensors will identify with this touch, okay, how much the surface hardness, or whether it is smooth or harder one, from physical interaction. Such type of things comes under the tactile sensors. Tactile sensors are devices which measures the parameters of a contact between the sensors and object. It mainly measures the parameters of a contact between the sensor and object. Tactile sensors can complement visual systems by providing added information when the robot begins to grip an object. Okay, always this uh, sensors give some additional informations whenever this robotic for using for some holding some grip, as if you are using that gripper as a tool, where that particular gripper is having the tactile sensors. In those cases, this particular tactile sensors will give some added information whenever that gripper is touching that object. Okay, for example, if you are using normal vacuum grippers or magnetic grippers, they won't have such type of like uh, added capturing information capability, but these tactile sensors will provide that added information. Okay, at this time, can see that different properties object can be determined by this particular sensors. So by you can determine the weight of the object, you can determine the what is the texture of the object, you can determine the stiffness, you can determine the thermal conductivity, other different things you can determine, such a way that these sensors will interact with the object to determine the weight, texture, stiffness. It will touch the object, and it will take that information related to the weight or texture or stiffness or thermal conductivity or other some other parameters. Okay, those things it will take that information. So these tactile sensing sensors will use some based on the different what type of sensing element that used, based on that it can identify the different no, parameters. So we can, those elements are, we can use the resistive elements, we can use the capacitive elements, or we can use the piezoelectrics, or other different elements also can use, like magnetic elements optical in related elements or conductive elements or rubber or ultrasonic, like that different sensing elements we can use. It may be a resistive, or it may be a capacitive element, or piezoelectric element, or it may be a magnetic or optical or conductive or rubber or different ultrasonic no, uh, elements you can use. So these particular can even here earlier also can mention the one the particular diagram in the that particular sensing element have this particular surface. You can see here also you can see different number of tactile elements are arranged in this particular surface. Okay, so to get the information from the object, this particular tactile sensor object have that sensing element in the particular surface. Okay, so one type of like a tactile sensor can see that particular especially that no, especially cricket, to find out the like bowler's action at how many degrees that he is rotating his entire arm to bowl the ball. Okay, whether it is he is doing any wrong action, for that the people are using this type of tactile sensors. Okay, I already mentioned that we can use different you know, sensing elements in the tactile surface. One such type of element is the resistive based sensors. So resistive sensors, these where we are going to use some resistors. Okay, whose resistance is affected by the physical quantity. Okay, we are going to use some resistors whose resistance is affected by a particular physical quantity. So it will generate some variation in the electrical output. That based on that electrical fluctuations, it will that measures the output. That is the like principle behind this particular resistive sensors. Okay, some physical quantity that you can measure by using the resistive effects are the, we can measure the temperature, we can measure the light, we can measure the deformation, we can measure the magnetic field strength. Okay, these resistive based sensors already mentioned that the main basic principle of the sensors is the measurement of the resistance. Already measured that whenever the object is subjected to some action, then due to that action the resistive elements resistance may get varied. Okay, so that is the main thing here. The main principle is the this principle behind the sensor is the measurement of the resistance. That measurement of resistance will be converted into appropriate value. That value may be a temperature or light or deformation or magnetic field strength. Okay, the majority of sensors, okay, most of the sensors, they are using the elastomers as the material that consists of a carbon doped rubber. So this is the most commonly used resistive material nowadays. Okay, you can see that here whenever some force is applied here over the object, okay, over the resistive elements, they get compressed. Okay, it will increase the particle density. Due to that, there is a variation in the resistance value. Okay, that resistance value will be converted into appropriate measurement value. That is the principle behind this particular resistive based sensors. Okay, and one more other different thing other than this elastomers, one other resistive sensing element is the strain gauge, where it is a thin film having the metal pattern that changes the resistance whenever it is strained. That is whenever it is deformed. Okay, there is change in the resistance value in the case of strain gauges, or some we can use also piezoresistive materials. whenever the pressure on the element, we are applying some pressure over that particular resistive elements, then they get compressed, we already seen, and there is a change in the resistance value. Okay, then this resistance value will measured, and accordingly that resistance value will converted into the measurable, like conductivity value or some force value, like that you can, it will be converted. So why the people mostly use this particular one is the this arrangement of this particular construction is very easy, and also it is very durable. Okay, even applying much massive loads or different loads also, it will work very effectively, and it will have the good dynamic range to measure the values, and easily you can read over the values. And disadvantage is there is a non-linearity regarding the sensitivity, because whenever you are applying certain amount of force over that, sometimes this particular relation, the deformation or compressions, will have that non-linear relations related to the measured value. That is the disadvantage regarding this particular resistive sensing element already. And one of the other resistive element is the strain gauge. Okay, this mainly strain gauge is sensor related to the resistance force sensor. It converts the force, pressure, or tension or weights into change in the electrical resistance. What we see in elastomers also here also, that whenever the strain gauge is subjected to a applied force is applied, or pressure is applied, some weight is fallen over that, then it will due to that deformation, there is change in the electrical resistance value. This strain gauge mainly consists of a grid of wire filament, that is a resistor. Approximately the thickness is 0.025 mm. This is bonded directly to the strained surface. Okay, this particular whatever the filament is there, that is bonded directly to the strained surface by using the like epoxy resin. You can attach this particular strain gauge to this particular surface. Whenever the load is applied to the surface, the due to that load, there is a change in the surface length. So surface, the strain gauge, your wire filament you attached. Okay, whenever the load is applied over the particular filament wire, that filament wire will get extended. Okay, due to that there is a change in the strain value. That strain value again will convert into appropriate measurable, like force value or pressure value, or related to the weight value, like that you can convert it. That is how that strain gauge is going to work. Okay, and other one is the sensitive material is the piezo resistive sensors. Okay, in piezo resistive material, like piezo resistive material is one that changes the resistivity when deformed. Okay, here piezo means in Greek it is a pigeon, that is the meaning is that to squeeze or press, because whenever we are applying some force or weight over the material, it is going to squeeze or pressing the inside grates. That's why that word came to this particular piezoresistive sensors. Okay. Yeah, this particular diagram will explain about the piezoresistive sensors. That is already we discussed, this elastomers is the mostly used material in the as a tactile sensors. A piezoresistive material is one that changes its resistivity when it is deformed. For example, you see this particular particles here. Okay, these are the particles. You can see they are conductive particles are very placed very far away or very apart. These particles distance is very far apart. Okay, when the some force is applied over this particular elastomers, then these particle will comes closer together. So then their conductive nature will increase so that the resistivity of the material is very low. Okay, whenever that particles uh, these particles comes closer together, because whenever you are applying some force over these particular elastomers, then these entire particles will come closer so that the resistivity of the material is very low. Their conductive action will get increases, but their resistivity values get diminished. Okay, that is how that particular piezoresistive sensors is going to work. So that's how this our tactile sensors is going to work. Today I explained about the tactile sensors. Mainly these tactile sensors are going to use different sensitive elements, that is sensing elements. Okay, mainly these tactile sensors will surface will whenever it touching the object, it will interact with the object to measure the maybe weight or force or some conductivity or different things, thermal conductivity or other different measurements it can perform by interacting this this with the object. For that it may use different types of sensing elements. It may use I explained about the resistive elements, I explained about the capacitive elements, and I explained about the piezoelectric type, that is where elastomers comes under the piezoelectric type of sensitive material. So that's it for today. Thank you students for coming and listening to my class. Thank you again.